Let's say we have a coin that is not biased, it's an unbiased coin, which is going to give us one of the two results when you flip it, right? It's going to give us either head or it's going to give us tail. And let's say we flip it again. So we flip the coin again, and it's going to give us head or tail, considering the coin is unbiased. Again, if we got tail the first time we flip it, we're still going to get either head or tail. So you can see where I'm going. The first event, no matter what happens, has no impact on the second event because the chance of me getting either of them is the same, right? Out of these two coins, either head, say out of these two possible outcomes, either head or tail, which means the chance of getting each of them is 50%, one half. So let's flip it again. So again the same outcome, head or tail, and head or tail. So I will be getting either head or tail. Now see, it is increasing in an exponential fashion. We had 2, became 4, became 8, and it just goes on and on. So the possible outcomes when we flip the coin 3 times, okay, are these going to be head, head, and head, 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 and head, 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 and tail, head, head, and tail, or it's going to be head, tail, and head. Well, it does look like it messed up here. Should be here. Okay, it could be head, tail, and tail. So 4 of them, and then we'll have 4 more, right? So it's going to be tail, head, head, tail, head, and tail, and then tail, tail, head, tail, tail, and tail. So we have total of 8 different outcomes when we flip the coin 3 times. So see, this is increasing in an exponential fashion. Now if I ask you the question, what is the probability of me getting all head out of all these flips? Well, you can see here my sample space, this is my sample space, and this is the only chance of my 3 heads, right? So there's just once that the 3 headers appear, which means the probability, as you can guess here, is 1 divided by my total sample space, which is 8. Now, is there any better way to actually do it? I mean, just think about it. When you flip it 10 times, I mean, you can go on for literally years trying to find number of possible outcomes, which means, so what we can do is use some logic to reason here. See, our answer was 1 over 8. And as I say, the flipping of the coin was unbiased, which means since there are 2 outcomes, so the chance of getting head is 1 half, or at least one of the outcome is 1 half. And the same chance in the second flip as well, and it's also 1 half on the third flip, which means can we perform 1 half times 1 half this second flip times in the third flip has 1 half chance. So getting 3 head, okay, is 1 half in each of the flip. So multiplying them is going to give us 1/8. And this is one of the rules of independence. When an event is independent, what we do is we multiply them together. So whatever the result we get on the first is not going to influence the result on the second. And this is the case of independence. In this scenario, we can find the probability by multiplying each of these events occurring 1 half times 1 half times 1 half. And there we go. Whereas let's say another incident where there is extreme dependence. For instance, this diagram here, we have, let's say, A and we have B. Now, what does A tell about B? Well, if A exists, it's a guarantee, it's a fact. B is not existent because B is not together with A. B is disjoint from A. So this is the case of extreme dependence where the probability, if A exists, probability of the B given A that already exists, here will be 0 because there is no part of B on A. So this is the case of extreme independence.